this is Jessica Braithwaite. My topic is addressing fraction addition and subtraction errors. I chose this topic because I honestly did not truly understand fractions until I took Dr. Strawhecker's math classes while I was getting my Bachelor of Arts degree in teaching as a 22-year-old. I found it utterly fascinating that fractions actually had meaning and could be understood and worked through instead of simply being looked at with procedural drill and kill, like invert and multiply, take the denominator times the whole number and add the numerator, etc. Honestly, I got fairly good grades when I was younger. But if there was ever anything that involved critical thinking, like a story problem with fractions, I had absolutely no idea. I had no foundation of conceptual knowledge of fractions when I was younger. I honestly didn't even know that it existed. I thought it all had to be procedural. Just if you knew what to do, you could get the right answer. If you didn't remember the procedure that the teacher told you, then you weren't going to get the right answer. I always want to learn as much as I can now so that I can stop this bad cycle of this happening to students. Throughout my presentation, I will have little funny memes. They're funny, but honestly, pretty realistic, like this one here. The teacher's saying 5/3 of the class don't understand a word I'm saying about fractions. A lot of the time students don't know what the teacher's saying about fractions because the teacher himself or herself doesn't understand what they're teaching or why they're teaching it. In my article, there was the author that had a study of teaching kids mathematics through a way that it was conceptually based so they'd have a good foundation of fractions and adding and subtracting them. She had a purpose and intention before she began her lesson. I think a lot of times that's what teachers forget in any subject that they're teaching, that they have to know going in what is their goal for the lesson. Her goal for the lesson was that students would have a conceptual understanding of the fractions, that they would not only know the number of pieces in a whole, but also the fractional size of the pieces involved in the problem. For example, 3/4 can be thought of as 3/1/4, and they would know the size of that compared to, say, what a sixth would look like. She also presented problems to the students to begin learning their information about fractions through story problems. All of the problems that she gave to the students were story problems, critical thinking story problems. So when I go back to what I taught my kids and how I learned when I was a teacher, I began by teaching them how to add like denominators just by using a number sentence, like 1/4 plus 2/4 equals what? Or 1/5 plus 3/5 equals what? Which that involves no critical thinking. So to begin with, she started with story problems and had them have to think it out and come up with the answers through those. Also, the students led the conversations and the thinking in the study. I thought this was great. They walked through their errors and misconceptions themselves. And honestly, there weren't a lot of errors or misconceptions because they were talking it out on their own. And they were looking at what they were doing and not listening to what the teacher was telling them to do. I found it pretty novel, however, that she did introduce a misconception as a question. So the problem was something like 3/8 plus 1/8 equals what? And she said, well, why isn't the answer 4/16? And the students just thought she was crazy because they had the conceptual understanding that they were working with eighths and the parts were eighths, so they didn't understand why she would even consider it being 16ths because that's not what part of the whole they were working with. Also, student thinking led the progression of what type of fraction problem came next. I thought this was absolutely awesome. She did not tell the students what type of problem they were going to work on next, like adding unlike denominators or subtracting a fraction from a whole or that kind of thing. She let their thinking constitute what type of problem came next. I'll explain more here in my next slide. So I'm going to jump to this since we were just talking about it. So, and the student progression in the article looked like this. The typical progression that I've seen in a textbook and how I remember learning it, looks like this. We both started with adding and subtracting like denominators. But then look at the jump here. The student progression, the next step was adding denominators to get a mixed number. I have seen that they just jump right into adding and subtracting unlike denominators. Up here, the student wasn't ready for that step until step 6. So when we force students to follow a certain thinking sequence, their brains and their learning style might not be ready for it. So why not let the students decide what should be next, what type of fraction problem should be next. Here I gave a story problem example that she presented to the students, and as you can see here, the students started with 3 wholes minus 5 6 equals what? The good conceptual foundational understanding that these students presented is they knew that there were 3 wholes, and they knew that they were working with 6 as the parts. So they put 6 and then 12 of 12 and then 18 for 18/6. They had 18/6, they subtracted that. In the article, it was amazing. Honestly, I was in fact jealous of how well they understood fractions. They renamed this improper fraction to a mixed number all on their own without having her have to tell them what the right procedure was for it to be done. And looking at how the article connected with the textbook, I found that they both had the same common errors and misconceptions they found in children and what they did, like adding both numerators and denominators, and then failing to find common denominators and multiples. But what I thought was different, and I say here that there were similarities but differences, is that in the article, all of her ways to help students get over their errors or misconceptions were all conceptual with hands-on modeling. Here in the text, they say, you know, if you give a student a problem that has unlike denominators, to work on having students list a series of multiples for each denominator. Well, a lot of students aren't going to be able to do that. A lot of students, especially that struggle or have learning disabilities, aren't going to be able to do that. So I like the article's way of doing it with visual representation better than this procedural way. And then connecting the article to the dimensions of a productive classroom. There are 5 dimensions of a productive classroom that our text referred to, but I was just going to hone in on 2 of them that I thought the article really connected to and exemplified. So the mathematics part of it, it says that this includes developing procedural proficiency in conjunction with conceptual understanding. Well, this was definitely seen in the article. The students knew what parts of the whole they were working with. They talked through the problems. They moved in their own thinking sequence. You could tell they had a good foundational basis of the conceptual knowledge of adding and subtracting fractions. And you could tell that they were developing productive habits of mind. You could tell that one, they learned and had ownership of the procedure they discovered in one problem. They used that knowledge to continue the thinking of what they did in the past problem and add on to it in the next problem. The cognitive demand was definitely there. Like I said, she didn't start by teaching just number sentences. She had them really cognitively think in story problems, and they had to have a little bit of productive struggle first. But because of this productive struggle, there was a concrete foundation for what they learned. And they could use that procedure that they discovered and they developed to find out the problem. And it was also important that her questions were already pre-made because of her initial goals that she wanted for the students to learn during the study, and they were at the appropriate level. Also, she allowed the students to determine what thinking sequence came next, so then it was the appropriate level for them. And wrapping it up, I just want to end with this quote from the article that says to listen carefully to your students to determine whether the sequence in which they encounter problems involving addition and subtraction aids them in making connections and developing computational fluency. I have always talked about in this class how I think it's really important to have conversations with students, even in an informative assessment or a whole group or small group method, so you can hear where they're coming from and what their thinking is. I am definitely going to use what I learned in this article to help my own children who are going through the middle grades in elementary school right now. If they're having struggles with remembering the procedures, I'm going to back them up a little bit and help them get some conceptual foundation of why they're doing what they're doing and explaining to me what they're doing. I'm going to use it as a teacher in the future if I ever teach again as well. I don't want students to be scared of fractions like many of these memes have shown. I think a lot of people and adults and students all fear fractions because they're just not understood, because they were never taught that way. So I hope from me continuing to learn about fractions myself, I can break that cycle and people go for learning more about fractions instead of shying away from them.